Hi everyone, welcome back to another DSA problem. So today we are going to solve BSC traversal. So what does BSC traversal exactly means? Traversal means to traverse or reach every node of the BST, binary search tree. We have to actually look into the entire tree. We have to traverse one by one each node, and there will be different ways of doing that. So one way is in order, second way is pre-order, and there's another way post-order. So before we actually start with the code, I think we should actually read the prompt or maybe understand the theory part of it. So let's go ahead and understand how we are going to actually solve the problem. So while we know uh, in order is something like this. I mean, we are going down till the left side of the tree in the depth, all right, like 3 and then 5, and then comes your uh, right child, all right, and then we go up again, and then we check whether it has a parent, and then the parent is printed or the current value is printed, and then its right side of the child is printed. All right, right child basically means the lowest value in the right side. I mean, we are going to again, once we reach on the top side, topest or the very first element, or you can call root, we actually go to the lowest element possible. So we find 12 at the lowest or the leftist part of the tree, and then we go above again 15, and then we have 20, and then likewise we have pre-order, and then we have post-order. So I'll go through pre-order and post-order one by one. So as I go from as I write down the pre-order, I'll go by root. The very first thing is root, and then I'll go to 5, the left side, and then the left side. I'm going top to bottom, all right, top to bottom, and then I'm going to the left side, and then I'm going to the right side of it, and then I'm actually going to the adjacent part of this. I mean, adjacent to 5, or adjacent to the uh, adjacent or the offspring of the root, which is nothing but 15. Once I am done with this, I'm going to the offspring of the root, which is 15, and then I go to 12, and then I'll go to 20. So it is clear that we are actually going from top to bottom in pre-order, and in order we are going from bottom to up, but with a twist that we are uh, actually once we reach the root, then we are actually going on the next part, and again we are going to 12. I mean, again we go bottom to up is what the main concept about. And then post order we have 3, again bottom, and then 7. We are actually doing here one thing, that whatever offsprings are together, they are all coming together, and then we go up, and then we go and see whether there is another offspring. And then we do found that after we go level 1, I mean after we reach 5, then we realize that we also have something below this. We have 12, and then we have 20, and then we are going to write 15, and then we're going to write 10. So this is what the logic is about post order traversal. So let's get started. I'm going to quickly, I mean, I've already created a file, binary tree.java. So let's get started with the coding part of it. The very first thing I'm gonna do is I'm gonna create a main class, and my main class will be called binary tree in this case. And then I'm going to have a primary function, primary uh, where we actually run the code, which is static void main, and then args, I'm going to have a constructor void binary tree. What this constructor is going to do? Uh, I'm going to have, I mean, if you have not watched my previous video, please go and watch because it is very important. I'm not going to repeat. All right. So as we all know, I am actually having a tree node type of variable, which is root. And then I'm going to say this dot root equals null because initially we are going to have a root as null. And then this tree node, I hope you understand where am I getting this from. I mean, I'm getting from tree node Java. We have already discussed this in previous videos. Please go through my entire playlist if you want to understand about this concept. So now, as we are aware that we now have to insert into the binary tree. So I have also wrote code for this. I mean here, as you can see, I can copy and paste this entire thing for the insert part of it. I mean, I just want to explain you post pre and Inorder traversal. So let's not waste time on actually solving again the insert problem. So now what are we going to have? Now we are going to create three functions. Public void, all right, public void, three functions. Let's just name according to their name of their traversal. So I'm going to